Cool. Hello, everyone. It was a very quick transition. Welcome. Let me just go ahead and take our, daily attendance to see who's here. Okay. So we got Tuesday in the AM. Yeah. Good morning. Good morning, Roxana. All right. So we have. Let me go ahead and share my screen, and let me just take attendance. So I see that we have Fernanda, have Roxana. I see we have Sophia G. I see Shannon. I see Stormy. Also, we also got Rosa. Let me know if I'm missing anyone. So I have 6. Sounds about right. 6 so far in here. Okay, awesome. Oh, okay. We also have Shania. Welcome, welcome, everyone. Okay, cool. So I was thinking, I'm gonna go ahead and yesterday I was talking about one. We got Edgar. Yay. Cool. So yesterday I was kind of talking about problem number 1. And I kind of didn't really get to like directly finish it. Like I kind of just gave you some ways to get started, but we didn't really kind of talk about what was the answer for number 1. So let's take a look. Okay, so this is where we left off. But before that, does anyone have any questions about any support talked about before? So yesterday we talked about how we tackle number 1, how we had to use the first derivative test, how you want to just make sure you explain that in your work. When you're typing out number 1, remember to justify first. Like, does anyone have questions about how we tackled number 1? And again, these slides are on Google Classroom. Welcome. So I see more friends coming in. Let me just go ahead and put. We got James and Sophia P. Welcome, y'all. So I'm just opening it up and asking to see if anyone has any questions about how we decided to tackle number 1 yesterday. Remember, I had to use a linked tool. It's down here in order to kind of help support finding what the zeros of that derivative would have been. And again, if anyone's interested to talk about that, like actually how to find the zeros, just let me know. I'd be happy to. It just would take like 20 minutes. But you could also look it up. And we also talked about how when you are explaining your answer to number 1, make sure that you are making connections to big ideas. And I emphasized that I was using big idea number 3 and big idea number 7. Big idea number 3 is the first derivative test. And big idea number 7 is checking your endpoints of your function. Those are the 2 things that I'm going to be using. So according to the first derivative test, I kind of created these points sketch. So let's see, does anyone have questions about the point? And wait, we got more folks coming in. Welcome, welcome. Glad to have you all here. So for those that just came in, I was talking about what we did yesterday with number 1 and how I kind of got the sketch. Now, cool. So I don't know. So far, I don't see any questions. Feel free to feel super comfortable to ask questions in the chat, or you could unmute. Like, so everyone should be clear on how we got these y values and how we got the sketch, how we know whether it's decreasing, increasing, and decreasing. Awesome. So thank you, Rosa, for asking the question. So confused on how I got the y values. So first off, yeah, these y values. So like kind of like their positions on the graph. That's a very good question. So yeah, you definitely want to know how we got that. And how we got that is I used my OG function or my original function. There's a typo in that original function. So one sec. Remember that typo from yesterday. There we go. That was the original function that's on your mini final. And what you have to do, for example, if you want to find out, let me just lift this up. If you want to find out what the Y value is after you plug in 14, all you have to do is replace all the W's with 14. I'm just going to copy and paste this. And I would just replace all the W's with 14. And that should get me, for example, that first one, which is 84.83. So 14. That's all I did. And here's like a shortcut. To be honest, this is what you could do. I just copy this and I open up Google. I paste it, and I first have to make sure that the exponents have a little caret like this. And then I just hit enter. And look at this, y'all. It tells me the answer. So that's just been the shortcut I've been using. So you could totally use that too. Because again, this isn't about us being able to evaluate. It's more so applying the concept. So that's all I did to get the Y values for each of these. I plugged it into the original function, and you could use Google to kind of help you out there. Oh, let me go back. All right, let's see what's in the chat. Okay, perfect. You understand how we got 83.82. How do we use big idea number 7? Great question. So that's a great question. So let me clear this up, clear all drawings. So let me circle the ones in a different color in blue. So this one right here was a critical point. This right here was a critical point. This was not a critical point. Let me circle that one in red. This was an endpoint. Why was this an endpoint? So this is an endpoint, and that's big idea number 7 because wait, let's see if anyone's saying anything in the chat. Oh, there's an additional question on critical points. So let me finish up how do we use big idea number 7 in a second. Let me X this out. So anyways, this is an endpoint because, let me finish typing. This is an endpoint because the workers needed to be paid at least $14 an hour. $14 per hour. So that's an endpoint for our function. And I know this is annoying. Just so that's what makes this an endpoint right here, the one in red, and that's how I'm using big idea number 7. See, it's not a critical point. That's just where my function starts. And in reality, I mean, you could do the second derivative test to do a better sketch, but I can already see that this function is going to look something like this. Like if I was to just kind of connect the points and so forth. And because it's decreasing, it's going to go back down. Like I could already see that the function is going to behave this way. And this is going to be an endpoint that we have to check as well because we're trying to figure out at what wage will give us the most maximum employees. That's the answer. That's what we're trying to answer for number 1. And then there was a question about critical points, but before we go back on how we got the points that I circled in blue there about critical points, does anyone have questions about what I did here in this picture? And then it says, is that picture still part of question 1 or 2? It could be, I would say it's more so for 1. But you could also use a similar, like for the number 3 as well. You might want to analyze your function. And also probably number 4 when you're deciding what's going to be the best wage to pay the workers. first you want to consider what's a good minimum wage, and then you also want to think about what's a good amount of workers as well to hire. Do we have to include the graph? Yeah, I would think so. You want to at least include a basic kind of graph. I want to see how you're using the sign chart to make a sketch to make your point. You want to include some sort of the graph. And I would definitely want you to try this on your, like, do the sign chart and do it on your own piece of paper and put in that screenshot for yourself. Because I want you all to make the connections, this picture with what we got in our sign chart right here. Remember, this was how we got these critical points right here. And that's what helped us make this picture. The critical points helped us make the points in blue, but I had to add that end point, the fact that, hey, we need to at least pay them $14 an hour. So that's why I added that point in red. But yeah, so you do want at least a basic sketch of your function. That was a good question. So maybe I could read it out loud. Somebody just asked me right now, is it mandatory for us to go to classes right now if we know what we're doing? So no, it will not be mandatory for you if you are passing your classes. More so, it will be mandatory if somebody is not passing their classes, like they need the office hours. That's when, calls home and things like that will happen. That's a good question for us here to know that. I just didn't want to explicitly advertise that because then we want to kind of make sure most people utilize their office hours. But I'm letting you know right now, yeah, that is that's the case. It's not 100% mandatory if you're good in your classes and you're passing all of that. Okay, awesome. Cool. So I guess we're gonna go to Russ's question. So Russa wanted some clarity on how we got the points I circled in blue, the critical points. So that was from yesterday's lesson, Russa. You could also, like, in addition to me kind of giving you a quick explanation of that, you can also go back to yesterday's video. I believe I sent it on Remind as well, where how I got this. This is the critical points. It's on slide number 10. So remember what we did. I put my OG function. I took the derivative. I set the derivative equal to 0. But something different happened at this step. So usually at this point, we'd have to factor our function, but we couldn't use the Math Papa tool I gave you before to kind of help us check our work. In addition, this has decimals, so it's actually going to be more of a challenge to factor this. So I used the link tool down here. So that's what happened yesterday. One sec. And again, you are able to find the zeros of this function if you'd like to. The formal way would be using the quadratic formula. But again, I didn't want to waste like 20 minutes talking about how to do the quadratic formula. But basically is I took this function, I copy it, I put it into this calculator, make sure it's equal to 0 because we're trying to figure out when the derivative is equal to 0 because this is the derivative function. And we hit calculate and it does it for you. So it's going to find the zeros for you. Again, you could use the quadratic formula if you wanted to do this by hand. And it's in our big ideas packet if you're interested, but this is how I got my 2 critical points once more. As you can see, this will have the quadratic formula because it's an add. Anyways, because you see there's square roots in here, that's where that's coming from because they're using the quadratic formula to figure out the zeros. So these are the 2 critical points according to our steps. So once I did that, all I had to do is plop them on a sign chart and do the regular tests. Let's see if you have questions about our tests or how we got, increase, decrease, all of that. If I haven't done the draft yet, because oh yes, that's a good question. So someone said if I didn't do the draft yet because I didn't understand it, but now I have a start, do I still just do it or the final version? Very good question. I actually am not inputting the draft as a grade. So more so for people who turned in the draft, I gave them feedback. So for those who turned in the draft, they got the opportunity to receive some feedback. If you didn't do it, don't worry about the draft. You're just going to turn it into the final version. That's correct. So that's a good question. And Rosa asked, and the critical points are representing the answers for number 2 and 3. No, critical points are just a step to help you. So critical points, usually in your first derivative test, help you determine if you have any minimums or maximums. That's mostly the goal. In addition, first derivative test does tell you how your function is behaving. If there's a negative here, it means your function is decreasing at this point. Positive, increasing, negative, decreasing. This is going to help us sketch the graph to help us try to answer the questions. So this is not the answer to the questions. This is a tool to help us answer the questions. You still have to further interpret what these represent, which we haven't yet. So we haven't given an answer yet. We're still actually going over what we did yesterday. And then, oh, how do we find the answers? I'm confused. Well, Rosa, so again, first derivative test. So basically what you want to understand is we're using the first derivative test to help us sketch the function that we were given. So that's the first step. The reason why you want to do that is because you need to kind of have a visual to kind of help you understand what's happening in your graph, because we want to, for example, number 1 is stating we want to find the maximum amount of employees that we can employ at this company. We're using the first derivative test because we know the first derivative test gives us maxes and mins. Because it's going to give us maxes, we're going to be using the first derivative test to check whether that maximum is going to give us the highest amount of employees. So it's a tool that you're going to use to help you. So from this first derivative test, right, on slide 12, I made like a basic sketch of what the function could look like. If you look here on this picture, here are our critical points, right? These two were the ones that we saw. And this right here, we added due to big idea number 7. This is an endpoint. And again, let me repeat, that's because we can't pay the workers below $14 an hour. So that's why we call this an endpoint. And then to be honest with you, I don't know yet what the other endpoint would be. Like this should have like 2 endpoints. I don't know yet, but I don't really care about the other endpoint because I know for a fact that after it hits this maximum, it's going to go back down. And that's not going to tell me another maximum that's going to help me determine when I'm going to have the most amount of workers. So that's what we have so far. Let's see if there's questions about that. And again, you could totally review the video from yesterday. In yesterday's video, we talked a little bit about why we needed the first derivative test as well in this problem. So you could totally review that. Okay, let's see. Are there questions about this before we try to attempt to answer number 1? Will this video be on Google Classroom later? Yes, I am recording this. I could put it on, is it better to put it on Classroom or Remind? I usually been sending it on Remind. But I could also stick it on Google Classroom. Okay, we'll do Google Classroom for it, no problem. Okay, let's see if there's any other questions about my sketch. Okay, good, there's more questions. So the point x equals 58.166, and the point 141.83, oh, that was an 83, it represents the pay and the amount of worker. Yo, I love that. I love that you're already like trying to interpret what are the x and y coordinates. Yeah, so if you look back at the original problem, right, you had NW or something. That was the function, where N represents the number of workers. And this represents their wage. Wage. So the input is wage, N is number of workers. Number of workers. Therefore, it's basically WN So $14 an hour wage, number of workers. This is going to be a wage of $58.166 per hour with an amount of negative amount of workers. Of course, this point wouldn't make sense. Then we go up here, we have the wage would be a very nice high wage of $141 per hour with an amount of about 68 workers. So that's right. You definitely want to label and interpret your points. That's going to help you answer the question for number one. So that was a good one. So yeah, label your points. We have wage workers. That's how the coordinate points are organized here, determined on what the problem said. Okay, further questions on this visual? Let's see if we have any more. Yeah, that would be here. Well, that would be not a minimum, but that would be that they would pay their workers $141 per hour, but then they'd only have about 68 workers. If you pay your workers $14 an hour, you have 84 workers. So these are just like the major points in your graph. And if we go back to the problem, right, we want to figure out, and it's like, I don't want to switch my screen as the problem. So I hope you all have your mini final open. But if you go back to the problem, they're asking you, at what wage will we have the maximum amount of workers? Maybe y'all can think about this and answer in the chat. This is kind of like what a sketch of your graph looks like. Rosa, okay, Rosa, why do you say that? Yes, at $14 an hour, it looks like we're gonna have, yeah, now you guys need to just justify it now. So remember what we did. Big idea number 7, because of the endpoint. We did big idea number 3 because we used the first derivative test to make a sketch of these essential points of maxes and mins. And lastly, we looked at the sketch and we could see visually $14 an hour is going to give us the highest amount of work. It's at 84. So now it's your job to go ahead and explain and elaborate that on question number 1. And that's correct. The answer is at $14 per hour because you're going to get about 84 workers. Let's see if anyone has any questions. But again, that's your job to put all this together and explain and justify. And see what the steps that took, like the questions you're asking are helping us get to the answer because we needed to know, wait, what do these coordinate points represent? That was a very good question. Like, oh, what's workers? What's wage? Awesome. So I wonder if y'all want time to start trying to type out number 1 or if we should move on to look at how to start other ones. Again, I don't want to give the answers to everything, but at least to just how to start it because we're going to be done at about 11:30. But I mean, if you want to utilize this whole time, if you feel like you got it, you're free to, work on the mini final at your own pace, if you want to. You don't have to be here waiting as well. All right, let me know what works. I'll put the question back in the chat. If y'all prefer time to just work on number 1, or we could just move on to see if you have questions on other things. Yeah, that's right, Rosa. So N, the output represents number of workers. That's correct. For me, I was a little bit confused because when I first did this, again, I didn't make this task. Again, it's another teacher at the Impact School who makes it, and he's an applied mathematician. So, he really likes to add in like real world scenarios. But anyways, when I first did this, I kept confusing myself because wage, I kept confusing as workers. So that would trip me up because I'm like, wait, this is wage, not amount of workers. And that would mess up my input and output. So that's why it makes so much sense to just label it. And on your paper, just remind yourself like, okay, this is wage and N is workers, not the other way around, which I would do. And I went ahead and I just put the question there. So I don't know what best works for the group that's in here. Again, if you want some time to work on number one, or if we could just go on and see what are the questions you might have on how to get started for the other ones. Again, I don't want to give direct step-by-step answers. I do want you to like more so give some hints on how to get started. Okay, cool. So we got one preference there. Okay, yay, okay, awesome. Again, this is going to be uploaded. It should be recording. Hold on a sec. Let me stop my share. Let me double, yeah, it's recording. Just making sure I double check. All right, getting hints on the other questions. So let's see. Let me just open up the mini final for us. Let me share my screen. Okay. So I'm going to just click on the mini draft submission just because I do want to see like the comments that y'all made on these as well. It's loading. Okay, so we have an idea on how to tackle number one. Don't forget to make connections to big idea number 3 and big idea number 7. And don't forget to include a sketch. So yes, you want to include a sketch. Now, the number 2 is saying, now suppose that you want to maximize the income of an individual floor worker. So just one worker. Like, what's the highest amount just one worker could get? It's basically the question. And it says, what's that optimum wage to demand for that floor worker? Justify your decision mathematically. And let's see what feedback we had here. This is talking about, yeah, just one worker. And I'm guessing we'll have to do some workings around. So for question 1, we find the most workers we can buy. For question 2, we find the most money we can pay a worker. That's right. And you are going to be using these 2 things to make a final kind of decision. So that's exactly what we're doing here. So before we begin, like first off, so that's of one worker. So it doesn't look like we need to, like for example, we already made a sketch of the function, but I don't know if that sketch is going to necessarily help us, or the first derivative test, because the maximum isn't going to really help us here. The maximum in the graph is just going to tell us like the highest amount of workers. So if we want to figure out the income of an individual floor worker, what is something we could do? So let's see if anyone has ideas. What did you do in this one? Because I know there are some ideas here that came up when I looked at some work. And then if we turn it in today, will we be able to get feedback still? Yes, of course. I think I put the due date for Wednesday. As long as you turn it in by Wednesday night, I'll work on giving feedback for Thursday, and you should get some feedback for sure. As long as it's before Friday, you'll get feedback. So let's see, for number 2, what are some things that y'all did? This includes even going to another tool or anything like that. How can we figure out how much one worker would get paid? This one, I don't know if you even need calculus, to be honest. Probably don't. And it says, so we just have one worker, or one worker gets a raise. So yeah, imagine you just have one worker. How much can that one worker get in this company? That's what we're imagining. So imagine like one worker can be paid a certain amount of money. What's that highest money that this one worker can get? That's what we're trying to do here. And again, there's different ways. The amount they all make in one person. So just one person, the amount that one individual floor worker, the highest amount they can make. But yeah, just one person. I mean, we can look at our equation. Remember, number of workers was represented by N, and the wage was represented by W. So if we're only interested in one worker, okay, so we have an idea right here in the chat. It says plug in 1 for N. We could totally do that. So let's see, where would I do this? Should we go to Desmo? I'm trying to see like a way to plug in 1 so I could so y'all can see it. Let me just go to Desmos. Let me do that. I know some of you went to Desmos, by the way. I was trying to see if anyone would say it. So, like, some of you did go straight to Desmos to put this in. Let me go ahead and type the function out. So it's negative 0.00304 W cubed. Then it was plus 0.12 W squared. And we have minus 9.9 W plus 200. And double check if I have typos, anyone. Y'all see that? It says my connection is unstable. Okay, so there's a little thing that's like a thing. So first, let me just do N of W just to write out the whole equation. And, you know, without our calculus tools, of course, you're going to get a graph. And lo and behold, it looks very close to the sketch that we made, by the way. Except we have to remember that at 14, this was an endpoint because we can't go below it, right? It was at 14, 83.82. So we have our graph here. And one idea was mentioned in the chat to just plug in 1 for n. So I'm going to just copy and paste this down, and I'm just going to make this equal to 1. That's me plugging in 1 for n. But then nothing really happens. So I'm looking at this. I'm like, oh, how are we going to figure out what W or what wage will give us the amount for one worker? So it's still like, you know, how are we going to figure this out? That would be a very tricky thing to solve. It would be kind of tricky. I don't know if anyone has ideas for that one, or if you tried something else when you had a graph. And then Rosa, you're saying for this problem, this would be the maximum wage? You're saying 143, let me find it. Was it 143? Oh, 141.33, yeah. Was that a typo? I think it's 0.83, but it's not that bad. But what this is saying, Rosa, is this is saying for 68 workers, they get this wage, not one worker, right? This is saying for 68 workers, they're going to get that wage. So how do we figure out how much one worker can get? And then we have 68 times 141. Multiply these two. How come multiplying? So that one I'm curious about. No, that's good that you're not divided. Don't we just multiply the number by the number of workers? How come? So if we multiply these two, I'm curious about that. So this is the wage. Is that what y'all are saying? No. Let's see. Let me set this up. I think it was 833, by the way, guys. Sorry. There's a slight typo. It doesn't really matter. So this is dollars per worker. Dollars. No, this is dollars per hour. And you're saying we multiply by 68? Oh, no, divide. Someone said multiply. So let's see. Let's try the multiply. Multiply by 68.566 workers. Well, see, the problem is if we multiply this, nothing will cancel out. This method kind of only works. I guess what was being said. Something would have to cancel out for us to get like one worker, I guess. Well, let's see. There's more ideas. There's division. So Rosa said, shouldn't we divide the wage by the number of workers to see what every individual wage is? That's an idea. So just a raise for one person, there's still there's still workers, right? I thought there was only going to be one worker. Yeah, there's only going to be one worker. We're envisioning that it's just one worker, and we're trying to see how much money can that one worker get. That's correct. And then Rosa, you said divide. So shouldn't we divide the wage by the number of workers? So like take these two and then divide it. And you got 2.06. Yeah, I think it would be higher than 2.06. Wait, yeah, it would be. So one worker could definitely make more than that. But that's a good idea. Like if we were to divide this, because if you're still dividing these two, you still are under the assumption that there's 68 workers though. right? So how can we use this graph to kind of find where it's one worker? What can we do next? Those are great ideas, y'all. It's even pushing me to think because I'm like, wait, will that work? This is pretty cool. So what else could we do? I know some of you who turned in a draft did some other method. Perhaps you want to share. Okay, so Roxana, you're saying x equals to 1. So are you saying, when you're saying x equals to 1, are you saying the w? Oh, and look up where the y value. So we're looking at where y is 1. Is that what we're looking at? Okay, now Roxana, you put, oops, sorry. 1 comma 176. Is that what one person would get? Where x is 1, right? So x would represent, when you're saying when x is 1, will represent this being 1. This would be the wage being 1. So then we're actually looking at when the y value is 1 in reality. And then we have another one. No, that is the whole wage, 1 comma $176. And we have 1 comma 100. So, okay, you guys are saying like, we got to find where. So you're saying where the input is 1. So you're saying the input, that means the X. Okay, Rosa, now you're saying at 100, the Y value is 1. So we're saying we're looking for when the Y value is 1 or when the X value is 1, because there's different things that are coming up in the chat. So I'm going to go back to what Viviana, you first said, let's make n equal to 1 because n was number of workers, right? N is actually represented by the y value. So I agree that we actually want to look at where the y value is 1. So that's what we're going to look for. What's a way we could do that? So we could like, do you want me to just trace my graph and just see when y equals 1? Perfect. Okay, Rosa, you're okay, cool. So let's do that. So I'm just trying my best to figure out when this is going to hit 1. Then for some reason, it's very hard, I guess, because so let me just try to zoom in some more to make this work. Okay, we're almost there. Just tell me when to stop. I mean, is that the best we can get? 1.007, what do you guys think? So then if I move a little bit, it just goes below 1. It goes to 0.96. This is the, unless I zoom in some more, try that. Let me know if anyone has another method. I know there was other methods. I just want to see if you mention it. Then you said, but the line crosses at 100 comma 1. Does it? Where? Let me zoom out. So at 100, this is what's happening. It's 100 comma 10 actually. And then the strategy that y'all were telling me to do was find where the y value is 1, and we're approximating it right here. So that's what I'm trying to follow through with. And shoot, look at how much one worker would get paid. If only they're able to do all that work though, right? It's about 174 an hour or something. This is kind of the closest I can get. And y'all can make an estimate based off of that. No, you're good, Rosa. I think your questions are super helpful. What do y'all think? Do you think this is good? If it is, y'all can take a screenshot too. And notice how it makes sense with what the input and outputs represent. One worker, that's about 1.007, let's just say that, is going to be getting a wage of, I'm sorry, yeah, one worker, because remember it's W comma N. One worker is getting a wage of about 174 per hour. And then how do we know that that's the maximum that one worker can get? So in this problem, the x-axis represents the wage, right? And this is like the most right-sided, like it's to the right most of our graph. Like if we were to try to go back, for example, to be like, well, this is also at 1. I feel like I could find like a 1 over here. See, if I was like to trace my graph, I could find one worker. But at this point in the graph, one worker would only get about $95 an hour. This question is asking what's the highest one worker can get. So I'm going to go to the most right side of the graph to find that. And that's why we're choosing that most right-handed side, which is over here. That's like the highest X value, which correlates to the highest wage in this problem. Yes, that's how we're reasoning this. Does anyone have any feedback or questions though about this? I think it was about here. Oh, I got something better. 1.002. It's even closer to 1. I wonder exactly at 1 though. I wonder how we can get that, if anyone knows. Okay, so we could do n of w equals 1, a graph where the marks intercept. Maybe if we zoom. I want to try that. Can I try the n of w equals 1? Because I did this and then it gave me an error. So let's see. Okay. Yo. I wish I could shout you out if you want to be private, cool, but that worked. What do y'all think? It's an awesome strategy. Yes, Shannon, thank you. Wow. Y'all see that? That was cool. So you could just set n, like that was, or Viviana, that was your original idea, remember? So if you set n equal to 1, and this is, I guess this was just a different way to set it up here on Desmos. But if you do that and plot the original function, you get where they intercept and it will give you the location. At one worker, they're going to make about $174 and about 51 cents. Yeah, wait, dollars per hour. There we go. So, wow, that was awesome. Now I'm learning some new Desmos strategies too. Cool. Does anyone I was just worried it wouldn't work. It worked. Yeah, I was worried too. Like, awesome. All right, so now y'all are totally free to take this screenshot. Now though, you want to explain what we did. I think a major part of how we understood this question is making sure we understood again what the N and W. Well, justification, the screenshot is part of your justification. You still need to verbally explain what we did, right? What did we have to do? One way was an idea was we have to make N equal to 1. And we kind of struggled with that, right? Y'all saw we were trying to zoom in and try to figure that out. Initially, some of you were thinking we should make W 1. But remember, like the thing that represents amount of workers is N. So that's why we have to set N equals to 1. And you have to understand that just constantly remind yourself that this right here is your wage. This is the amount of workers. So just that was like super key. We just had to keep reminding ourselves. In addition, another thing we did is we had to look at the rightmost side of the graph because the more right, the higher the wage. So that's why we went all the way to the right and we found where N is equal to 1. So again, use the screenshot, but you want to explain what we did and why. So that will show me that you deeply understand this whole process and what we did. That was pretty cool. Cool. Let me know if there's more questions on this. Let me just, I'm going to put some coffee. Let me come back. Don't worry. But just let's see if there's questions on this more. If not, we could jump into the check out how to start on the other one. This has been great. This is awesome. All right, hello, welcome. Me welcoming back. So I don't see any questions in the chat, so I feel like we're good. So I'm going to go ahead and move on from this. That was number 2. It was excellent problem solving that we did together. That was great. Again, I will make sure I upload this recording. All right, cool. So we got number 1, we got number 2. Number 2 now, for example, if you want to say what big ideas we used, to be honest, no, I don't think we applied any big ideas. So more so, it was just applying kind of the algebra skills and just knowing what our input and output was, using the graph, so forth. So I don't really see any big ideas being applied here. But the only reason you were asked this question is so that you can combine what you got from number 1, number 2, and number 3 to kind of finally think about what would you as a union member try to advocate for a wage for your workers. All right, number 3. Okay, now it says, finally, suppose your goal is to maximize the total income received by the entire community of floor workers. So now we're looking, I feel like we're probably going to look back at the graph from number 1, or of course you could look at the Desmos. We also graphed it here, but of course I want to see you apply your calculus, use a sign chart to, applying the big ideas for how we got this graph. But of course your graph is here. You're able to obtain it using the sign chart and calculus. But let me go back here. Now, for number 1, we maximized the amount of workers. Number 2, we maximized how much one worker could get. Number 3 says we want to maximize the total income received by the entire community of floor workers at this supermarket, and what's the optimum wage to justify for the floor workers. Justify your decision mathematically. So let's see. So you could go back to your sketch, or we could go here, and we have to just remember that, oops. We have to just remember our coordinates. So just looking at our key points and just remembering that 14 was an endpoint, right? That was an endpoint. We have to at least pay them $14 an hour. What I could do is I could just make sure I make that a point. What was it? 14.83.82. That way it just stays there so we know that's an endpoint. Awesome. And then I don't need this at the moment. Okay, so now let me just go ahead and click on the maximums there again. So at these maximum values, just remember that these coordinate points, this represents your wage, this represents number of workers, and that's for all of this. So because, calculus, it directs us to look at these major points, right? And this one was 14, comma 83.82. And remember at this point right here, 83.82, this one gave us the maximum amount of workers, right? For number 1, that's what we were asked to do. But now number 3 is asking us what's the highest possible wage for all workers or for most workers that we could try to demand for. Looking at this visual, what do y'all think? And we're focusing on wage now in this next question. So we're focusing on the X values. It says for the community of workers. So we're not looking at one worker, we're looking for what's going to be the maximum wage for a good amount of community of workers. All right, so a lot of you are saying 141.83 or about $141 per hour. That's right. I mean, I would agree with you, not that's right, but like, how would you justify that? How would you justify that this actually would be a maximum wage for all workers? How would you write that like in a sentence? Maybe someone could take a stab at it. It's pretty straightforward though. How you would write it in a sentence is just look at what these represent. So for blah, blah, blah workers, they're gonna get this much money. Try and see if you could try it out. And then just think about why it would not be these, right? So, all right, I love this. We have this in the chat. Since it's furthest to the right on the graph and we're looking at the x-axis, oh, that's nice. So it is a maximum that's to the far right of our graph. And it's on the x-axis, the 141. So it's a very high wage, and it gives us a good maximum, a local maximum amount of workers. It gives it a good chunk. 68 workers getting that amount of money is pretty nice. And perfect. Here's another attempt. For 68 workers, they will each get a wage of 141. So I like both of those explanations. I really like the one that's saying about the furthest to the right as well, just because that's taken into account that it is a maximum, but it is a maximum that's furthest to the right on our graph. So we know that we're going to get a good chunk of workers first off, because it's more to the we're going to get a good chunk of workers because it's a maximum, and they're going to get a high wage because this maximum is very to the right of the graph. So that's awesome. I love that. And again, interpret your point. For 68 workers, they'll each get a wage of $141 per hour. Those are awesome. Cool. Let's see. Do y'all think, so this one you actually didn't have to redo any math. You're kind of referencing the math you did for number one, basically. And you're just looking at your points and interpreting the coordinates. Let's see. Does anyone have questions on this one? This was to kind of help us for number three. Not bad. Not bad. It's actually faster than I thought. You just now need to make your explanation. And again, this one you can make connections to the big ideas because we're still kind of using the fact that the first derivative test gave us this second maximum right here. So you could still reference our big idea number three. You could reference again big idea number seven because we still had to compare this endpoint. Yes, a wage of $14 per hour will give us like the most workers. But if we lose a little bit of workers, everyone will get a very nice wage, especially like I'm saying, Bay Area. And then, so Russa, you said, so 141 is the max community. Yeah, like it covers a good community of workers. It won't cover as good as 83 workers, but 68 workers is pretty good. Okay, any other questions on this one here? This was for number three. All right, cool. I don't see any questions. So now, I mean, you're all are in a good place. We covered a good chunk of how to get started on this. Like the main juice is going to be you putting this all together, making it convincing. Your last thing, number four, is up to you. You are now going to make, yeah, number four is your own opinion. Some people might say, hey, let's do $14 an hour because I want the more of my community getting a job. Some might say, well, $14 an hour, that's not that much. Like, would we rather lose a few to make a higher amount, which was the other maximum? Or, it's going to be up to you. Again, you're going to base your answer off what you saw in questions 1, 2, and 3. Or you could be someone who's like, hey, let's just hire one worker. That one worker is going to get $170 an hour. But would that be good for your community? So all of that are things to think about, and you're going to make your best choice for number 4. Does that make sense for everybody? Let me know if anyone has questions on that. So yeah, number 4 is your own. You're going to make your own justification. Again, you might have something different. Yeah, perfect. Okay, so I'm hearing, yes, it's making sense. Cool. All right, awesome. So if you don't have any more questions, you're basically free to get to work on your mini final. If you want to stay here and ask any additional questions, you can go ahead and stay. But yeah, other than that, you all are free to go. Good luck. Yeah, good luck, everyone. Bye. Good luck.
Mr. Dono,
Yeah,
if I turn it in, you'll still give us feedback, right?
that's right. Yeah.
Oh, okay, cool. Thank you so much.
Yep, you're welcome. Thank you so much for your amazing thoughts and guidance on this problem too.
Oh, no problem.
See ya.
Bye.
Bye. Yay, that's awesome. All right, and let's see Shannon, Israel, and I can't see who that last person is. Let me know if y'all have any questions. Oh, it's Kaylin. Um, if not,
Okay, I have a couple questions. So my first, it was just in my head. My first question, and like to receive cause like, is this going by you know, I don't remember like proficient and advanced and all that.
yeah.
Is that how that's being graded? Okay, and so like to get advanced, you refer to the big ideas packet, right?
That's right. Yes. And if you'd like to, I mean, it would be great. It's a push. I don't know how if you would, be able to do this, but a push would be try to kind of incorporate how second derivative tests might help you out here. I mean, for sure, second derivative test helps you sketch the graph, like concavity portions of it. Um, and by the way, second derivative test will be way easier to find the inflection point, let me tell you. So once you have the first derivative, second derivative will be, you won't even have to use a tool. Um, so you can find the inflection point, determine what does that inflection point mean, like as far as the business or profits of this, you know, this
Hmm.
company. You could try, it's a push. I'll see what you create with that, but I definitely would want to see some inclusion of second derivative tests. But other than that, yes, make sure you're making connections to the big ideas, so forth. um yeah, let me know if you have more questions on that.
And yeah, I did have an additional question. I don't know what it is, but like, cause I don't like the third question is really tripping me up. Cause to be honest, I don't know, like it's just not clicking in my head. Like I really don't understand what exactly I'm looking for.
Right.
Like, am I looking for the whole team? I don't know. Like I don't know what
Yeah,
I'm.
to be honest, like it says the entire, I a little bit got tripped up by the language here too, because I'm assuming like, wait, is there an entire community? Like, is there a fixed number that we're looking at? But the fact is,
That's why, cause like I'm thinking like I'm thinking like this wouldn't work without them giving us like what is the entire community like. I don't know if I'm just reading it wrong, but
no,
like yeah.
I agree with you. I agree. Like I said, I didn't write this, so for me, I was a little bit tripped up by the language. I would have kind of reworded this to say, what is the maximum income that could be received by the most amount of workers, maybe? Or for
Okay.
a good part of your community or a good size, like, kind of, that's how I'm interpreting it when we're looking here. For example, like, is the entire community, like, is the assumption that it's only it's, hey, where is it? It was about 84, right? Where was, oh, about 83 workers, right?
Yeah.
So that's how, like, I took it as like, oh, does that mean we need to fire people to get to that
Right.
maximum? It
Yeah.
depends how you interpret it. I interpret it as that we probably have to lose or let go of applications to actually make sure that most workers get a livable wage. Or you could be somebody who's
Hmm.
in between here, you know. But if you go below that, you're going to lose even more workers, right? Because that's a maximum, and we're going to lose more. Um, so this point would benefit about 68 members of the community. This point would benefit about 83. So it's basically like, it's up to you. I interpreted, like I said, I interpreted that we'd have to let go a few people in order to benefit the majority of the community, which is kind of like, it sounds horrible. It
and
sounds
that
horrible.
and that's another thing. Like I thought every point past like at the first X intercept, I thought any point past that was like not like realistic. Like I thought I couldn't use because like
Like here.
I don't know. Like there probably are minimum wage job or there probably are jobs that like pay like 100. Yeah, where there is jobs that pay 100,000 an hour. But like I don't know. I just thought that like I don't know why in my head.
Oh,
Yeah, like every point, like not the negative
oh, you're saying
Y values. That whole yeah, I was
saying
like
that is not possible. I do know
that's why.
there are people with these kinds of wage, but they're like engineers. So
Yeah, that's why I was like I wouldn't.
hey, maybe in the future, but I get you can do that too. So that is a thing you can do. Like I don't think a supermarket employee can be paid more than $100 per hour. So I'm gonna just stop my graph here, and then I'm going to analyze just this chunk. That's a perfectly acceptable as long as you're able to justify it.
Right. Oh, okay. So like any okay, so any answer is like you just have
Very
to make
open
sure it
ended.
makes
Yeah, as long as you're like if you're saying you're a real person, let's say you're a real, but you're a union worker. You want to envision you're a union worker, and like and in addition, like right in this graph, like it'll be fun. It's funky because like even if you did restrict it, the highest amount that a worker could get would be like $29
Mhm.
an hour, right?
Yeah.
You'd ignore the negative, so it'd be like you'd be restricted to like only this chunk right here.
Mm,
But it's up to you. Like as long, you could analyze it and use the first derivative test, but then you could be like, but I'm gonna make my endpoints using big idea number 7 here and here to make a reasonable estimate as to how much this employees would get and how we could keep the maximum amount of workers. But yeah, so but I'm kind of hoping this company could do this crazy stuff where they could actually pay their workers a lot. I don't know.
okay.
I
And then I had one more quick question. And they said to justify it mathematically.
hmm
Did did you like like to like evaluate the equations or did you just mean like with the screenshots of the graphs and
Yeah, so
whatnot?
mathematically justification could be so for number one, first off, I definitely do want to see the sign chart and first derivative test being used to determine the
Mhm.
maximums and minimums. After that, of course, you could use Desmos. So that would be your justification. And then for the other ones, yes, a screenshot and a graph is enough. You don't have to actually plug in and evaluate unless you really want to verify your work. You could totally do that.
Mhm.
But
Would it be okay to screenshot from those from the resources you gave us, the eMath help,
the
the calculator?
Yeah, that's totally fine too. Yeah, the zeros calculator, that's an option as well. Yeah, of course. Just keep in mind, like I don't know, in the college, if they ever ask you to find the zeros without a calculator, just make sure you know what to
Right,
do.
yeah.
Right? Yeah. But yeah, that's pretty much it. And it's on the big ideas packet. If you look at how to find the zeros, I put like there's box method. The box method wouldn't have worked here because the decimals. So the only other alternative for this would have been the quadratic formula. Again, it's going to be very long, but you can feel free to test it out to see if you get those zeros. But yeah,
Mhm. Okay. All right. Okay.
yeah,
Thank you.
yeah. Feel free to also ask any more. Feel free to also, as usual, you could text me and remind as well.
Mhm.
Um,
Yeah, I think I got it though.
Yeah, but I'd be super interested if you are going to cut this function down more, like to justify your work. That's going to be very interesting to see. I'd love to see it. But if not, that's okay too.
Hmm.
You can do this any way you desire.
All right. All right. Thank you so much.
Yeah, of course. You're welcome. Can't wait to see what you come up with.
All right. I'll see you later.
See ya.
Bye.
Bye. And Kaylin, are you good there? Do you have any questions? Oh, okay, about the late work. Yeah. So yeah, what questions did you have about the late work? You are still able to turn in any late work, by the way. So anything that you're missing. But I would totally would recommend the summative is huge. So this mini final, focus on the mini final. That's gonna be the majority of your credit. But yes, I'm still accepting all work. Try to get it in before Friday though, and then just send me an email. Um, So if I turn in the work today, it's going to be quarter 3. So we haven't yet started quarter 4, but of course, quarter 3 does impact quarter 4 because we're on a semester system and semester goes with quarter 3, quarter 4 combined, and then that gives you the semester grade. So it will do quarter 3, but it also, kind of impacts your quarter 4. So I would say both. It does affect both, but mostly right now, quarter 3, since we haven't started quarter 4. Okay, perfect. All right. I'll look forward to it. Let me know if you have any questions. Feel free to text me on Remind. I'll see you and good luck in your presentation. Bye.